Okay, so we've been talking about patterns. We've been talking about patterns and learning how to recognize patterns as being linear, learning how to recognize how to use a rule to define a pattern, right? And then last time we were here, we looked at that worksheet where some of the patterns that we did were not linear. And we're going to continue that today and talk a little bit about patterns that aren't linear. Now, guys, we're not going to be focusing on finding rules for nonlinear patterns. There are some, and you will definitely be working on that in future classes. And you might recognize some of them today as we go through these. And so you can recognize those, and we'll talk a little bit about them. But what we're going to be doing is learning how to continue a pattern, right? And find more terms in a pattern. All right? Now, not all patterns are linear, but linear patterns are really easy to recognize. What is the one thing that makes them so easy to recognize? They have a common difference, exactly. So if you do so that's why we do at least the first two of them to see that we're getting a common difference. So what happens with patterns that aren't? They're not going to have a common difference. So we have to look for different ideas to be able to find out and explain what's happening. So we're going to look at a couple of patterns here. You need to tell me are they linear or not. And then if not, even if they are, we're going to learn how to describe them in words. And of course, if they're linear, we can write a rule for them. Right? Everybody ready? Okay. All right. So for each of the following sequences, we're going to decide whether or not the sequence is linear. If it is linear, we're going to find the formula. If not, then we want to find a pattern, describe the patterns in words, and then we're going to find the 10th number in the sequence. And we're going to work on some of these together, and then the rest of them you're going to work on yourselves. Okay? Now, it's important to be able to recognize these because you can then use them for problem solving and other types of activities, right? So here we go. So let's just begin with the first one. So we have 34, 37, 40, 43. Many times it's easier when you're working with a pattern if you'll start by creating a chart. Okay? And remember the chart is N and T, where N is the number of the pattern and T is the value. So the first value in this one is 34. Second value is 37. Are we freezing? Why are we freezing? Okay, there we go. Okay. Pardon? In your notebooks, yes. So we're doing this first pattern. Right, we're doing an example. Third number in the pattern is 40. Fourth one is 43, and then, of course, the ... means it goes on forever in that pattern. So the first thing we need to do is check to see if it's linear. How can I check to see if a pattern is linear? Common difference. So we have 37 minus 34, which is 3. Then we'll do the second pair. 40 minus 37, which is 3. So what are you thinking?
Me is thinking
common difference, both linear, yes. So that means that this 3, becomes the multiplier for your n, right? So t equals 3n. And since then we just take the first number and either add or subtract our common difference. Since it's positive, I'm going to be careful, subtract. You're going to you do the opposite. So that gives us 31, so positive 31. Okay? So that one happened to be linear. Now, let's describe the pattern in words. This is something that you're going to be asked to do. So let's describe it in words. So, for each number, I'm going to multiply it by what? 3. And then add what? 31. So to find the next term, right? To find the next term, multiply by 3. Multiply n by 3 and add 31. Okay? So keep it simple, but make sure it's a descriptive enough sentence that someone else could be able to do it. Now, they also want us to find the 10th number in the sequence. Well, that's pretty easy when it's linear and we have a formula, right? We just put 10 in place of what? N. So T equals 3 times 10 plus 31. Be careful.
61.
T equals 30 plus 31, which equals 61.
Wait.
Okay. Multiply N by 3 and add 31 to get any term. All right? So, that one was linear. The rest of them might not be.
Oh no. I don't like how you sounded when you
Let's
said
see.
that.
So let's see what we've got. Everybody got what they need written down from this?
Yes.
Because I'm about to clear it.
Mr. Self, you know that like you could just not give us
Yeah.
this, and that would make everyone happy.
Shh. All right. We done, guys? Are we done with this?
Wait, hold on.
Hurry, tell me.
If you just like didn't give us this, everyone
I
would be
just
happy.
immediately just.
So let's look at number 3.
Is it because number 2 isn't a linear?
No, it's just because I just want to do number 3. You want to do number 2 so badly? All right, let's do number 2.
You said number.
All right. Remember, so the number and the term. First, second, third, and fourth. 7, 10, 15, 22. So first we'll do test if it's linear. The test for linear is to simply do a common difference.
It's not.
10 minus 7 is 3. 15 minus 10 is 5. Automatically we see that it is not linear, right? So the question to the first part is that it's not linear. Okay? So that's the answer for A. Okay? If it is linear, find the formula. But if it's not, look at the differences between each term and see if you can find a pattern. So in this one, we're just going to continue finding differences to see if we find a pattern. So the next one would be 22 minus 15, which is what? 7.
Goes up.
Are you noticing the numbers? Yeah, so what's happening? So to the first one you add what? 3. To the second one you add 5. To the third one you add 7. So what do you think you're going to do for the next one? Add 9. Then what? 11, etc. Right? Okay? So we can continue the pattern. So even though you don't have a rule for it, and you can still continue the pattern. So what we need to do then is describe the pattern in words. So what's happening?
It's
Okay.
You're adding odd numbers and increasing in consecutive order.
Okay.
Odd, I don't know. So,
But we need to know where the pattern begins. So I need to be able to tell someone so they could replicate this. So this one, because it's not linear, we need to have a starting number, right? If it's linear, we don't need one. Okay.
so go start with 7.
Start with 7.
And add 3. Then for each further term, got consecutively in odd numbers.
So each consecutive number
Each odd consecutive number.
add the next odd number.
Yeah.
That does it. You could probably write a more elegant sentence, yeah, if you had more time. But just pick something. But you should be able to describe it in a way that someone else would be able to understand it.
You say start with 17, add 5.
No, it says add 3.
Wouldn't it be easy to
Oh. Wait, what's...
Sorry?
Wouldn't it just be easier to write the rule for it?
All right. Do you know the rule for it?
N squared plus 6.
Is it though?
Yeah, it is.
It is.
You know what?
Just bad girl. Yes.
How?
I'm a bad girl.
All right.
Wait, this is...
I was saying.
Oh, yeah, it is.
Right. This is a quadratic pattern. But at this point in your life, you're not supposed to know that. So, yes, you can write the pattern if you know it, but otherwise just be able to describe it in words is plenty for what we're doing. Okay? All right? Now, we need to find the 10th pattern, number in the pattern. How can we do that? We could just continue. So to 22, I'm going to add what? Guys, for 22, we're going to add what? 31, and then it's 31 plus what? Is 42. And where am I?
Could you teach us how to find the rule instead of writing the rule?
This is the curriculum. Hold on. All right. So 42 plus what? 13 is?
55.
Okay. 55 plus 15 is? 70 plus 17 is? And finally 87 plus what? 19 is?
106.
What now?
606.
Okay. All right. So there's our 10th term. So even though we don't have a rule for it, that doesn't mean we can't continue the pattern. Right? So that's what you're going to be expected to do. You're going to be expected to continue the pattern and write down the numbers up to a certain point. Okay? Now, in this case, they're all the 10th number in the sequence. But in some cases, they may give you a value. You need to write them up to a certain value, up to a certain number. Okay? Where might I be hinting that you might need to do that? So, all right. Does everybody have this one written down? Everything they need written down from this?
I'm writing this all in my notes.
Perfect. That's where it should go.
I've been writing all of this down examples.
Doesn't matter. Okay. Are we ready?
No.
Then
Start
add
at 18.
5.
Okay.
Keep
So
adding
the
to
next
the 5.
number add 7 and then the next number 5 and 7.
Add 5, period then. Okay.
No.
So that's add 7.
No. Could you come up with a better sentence? Probably.
But
Would you be able to do that?
Would that sentence be right?
So maybe not repeat. Maybe continue. That or not. It's up to you to come up with an elegant sentence, not me. Okay? No, definitely not linear. Okay? So you're starting with 20, then you're going to add 5. To that sum, you add 7. Then you're going to add 5 to that sum, then 7 to the next sum. So now what we need to do is write it out so that we can get the 10th pattern in the sequence. So we have 4 of them, right? Okay. So now let's do the 5th one. It's going to be what? So we have 44
49.
plus 5 is 49. Yes? The first one was 20. So 1, 2, 3, 4. Oh, we have 5 of them, yeah. Yeah, we did because we have 20. So we already had 5. So that's 6. This is 7. Good. We already have more. All right. So then 49 plus what?
7.
Is?
56.
There you go. And the 8th one is going to be 56 plus what?
5.
Is? Then the 9th one is going to be 61 plus
7.
which is 68. And then finally, the 10th one is 68 plus what?
5.
Which is? And there you go. You have your 10th one.
73.
Okay? All right. Take a minute to write it down.